Hello, everybody. So my name is Victoria Augoustides. I currently go to NC State. As Teresa said, I graduate in May, which is kind of crazy for me, honestly. I remember being a high school senior, and it was wild then, but it's even crazier now because I actually started grad school at UNC in the fall, which is also kind of insane. So let me go ahead and so today what I will be talking to you guys about is I will be trying to convince you that I was supposed to be able to move my video around, but it's not letting me today. So we're just going to roll with it. I will be trying to convince you all today that SpongeBob SquarePants, yes, SpongeBob SquarePants. I know you all grew up with SpongeBob. Maybe, maybe your parents didn't let you watch him, but just purely the Sponge himself, I will be trying to convince you that he is the same as my research project. And yeah, like I said, I'm having trouble moving my video around, but we will just keep rolling with it. So my research project is in waste management. And waste is really an important topic because waste is all around us. And my background is in chemistry, biology, physics, engineering, and that has allowed me to explore everything from growing cells that glow in the presence of cancer to designing bridges and air conditioning for your house. With this broad background, I was privileged to pick and choose what my research would be in college as an undergraduate. I chose research on making biological innovation from waste. Waste comes from everywhere and everything. Everyone in the audience today, I'm sure, has seen waste before. Maybe it's the food scraps from a delicious dinner that you made. Maybe it's a pair of shoes that you've thrown away because they were too small to use anymore. Can you guys put in the chat for me, kind of like we did just a second ago, about where you were from? About like the last kind of waste you saw. So maybe that was your dinner waste, maybe that was some clothes you threw away, maybe it was some trash you saw on the street walking to school. So if you guys can just put that in the chat, we'll come back to that in a little bit. So I really believe that a lot of the problems that we face in the world today. So on the far left, you can see this is some drought that is in an agricultural field. There's not a lot of water, the ground's all cracked. You can imagine the problems this would cause if you're trying to grow crops. And then in the middle, we have this huge pile of food waste from a grocery store that people were throwing out. It probably shouldn't have been thrown out, in my opinion. And then on the far right here, we have new medicine. So what does all of this have in common? All of these things can be solved with waste and created with waste. And I know like food waste is like, well, isn't this already waste? Yeah, but there are other ways that you can use another type of waste to treat this kind of waste. And we'll talk about that in a second. But in my research, I'm turning everyday materials as well as agricultural waste into powerful tools to remove contaminants from water. Specifically, I'm turning pine bark into biologically activated carbon to remove compounds from swine waste. So let's talk a little bit more about activated carbon. Before we do that, we go ahead and look at what you guys said. Oh, so many answers. Thank you guys for being so engaged today. Water waste, this more water waste, pistachio shells. We actually use some pistachio shells in my lab. That's really cool. Old tire in the road. Thank you, Ava. Water waste, food container waste. That's another really good one. Paper waste. Paper waste is a big issue. Banana peel, orange peels, cereal bar wrapper. Wow. Mango peels, organic waste, water bottle, Slim Jim wrapper. Thank you for the specificity, Ryan. That's great. So all of these different things, if you think about the atoms at the base level, all of these different things, for sure, if it's an organic waste, so if it comes from nature, it probably has carbon in it, and which is a great segue into activated carbon. So what is activated carbon? Activated carbon is a really special and a simple yet very powerful technology. If you think of some common household items like you put in the chat, another common household item I'm sure maybe some of you have is like a fish tank or a Brita filter. things that filter water out. These very likely have activated carbon in them because activated carbon works through filtrating contaminated compounds from the air or water and getting them caught in this pore matrix on the left. I don't know if you guys can see that, but on the left of the screen, you have all of these little channels within the carbon itself. And that's how it works to purify your water and your air. And we actually make that in my lab. So this phenomena is really important when thinking about how we can turn waste into activated carbon to be used to solve the contaminants released from other waste. And so when you think at the molecular level about what that actually looks like, there are two really important things. There's absorption, where particles from one substance are being absorbed to another. But there's also desorption, where those particles are breaking apart and being released. And so, as engineers and scientists, once we understand how one material behaves with the other, we can control it and use it to solve problems at the tiny molecular level. And you'll see that in a second. But I told you, right? SpongeBob has a lot to do with science, funnily enough. And so when we think about absorption, it's really important to think about what's happening at that molecular level. And there's a lot of different factors that come into play here. There's size, shape, and these determine how those particles are actually going to fit into those little tiny channels in our activated carbon. So again, looking at SpongeBob, you can see he has, I'm going to draw on my screen here if I can, annotations. Here. Not letting me. Okay, well, as you can see on the SpongeBob himself, you can see all these little circles in him, right? If you think of your kitchen sponge, there are all these little places for particles to get trapped. But you can't fit a square peg in a round hole, right? So you have to really think about, when you're designing this material, is my material actually going to be the correct size to pick up what I want it to? Is my material the right shape? The other thing that's even, I think, is really cool is electric attraction and chemical bonding. So I'm sure some of you in high school or maybe even middle school might have learned about this. So for my younger students, I'll explain this. All across every material, there are different positive and negative sites. So positive being it has a positive charge, negative being it has a negative charge. When those materials interact with each other, positive attracts negative and positive repels positive. There's also, and when you get into high school, you'll learn about pH, but being in the correct pH also matters. And so SpongeBob here has to be positively charged in order to attract the negative ion. So we've designed this material, being SpongeBob, with circular holes of a certain size, positive, because we want to attract these negatively charged circular objects. And there's also some chemical forces at play at the very molecular level, but we won't get into that today. And so everything else that's in the solution with SpongeBob is going to be rejected and not picked up. So that's another important factor you can think about is maybe we design a material to pick up one thing, but to make sure we don't pick up another thing. That can be really important in engineering context. So we'll move right along. So what do we actually use in my lab? The thing that we use most of the time is pine bark and pine wood. And so we take this natural material. If you ever go to a forestry site where they're harvesting lumber, they cut down the tree, it falls down, and then they run it through this machine, and all of these wood chips and bark spray off. They're skinning trees, essentially. What do you do with that? Well, I'm sure a lot of your parents probably have mulch on their lawns, but that's a really cheap material. It doesn't actually add any value to the waste product generated from this process. And forestry, pine bark specifically, is a huge industry here in North Carolina. Loblolly pines are actually the most cultivated species in the Southeast. So we chose a waste product that would really hit home for North Carolina. And so we take this raw material and we throw it, this is really cool to me, we throw it in an oven at 700 degrees Celsius, or about 1,200 Fahrenheit. You think about it, on a hot day here in North Carolina, it might get up to 100 degrees Fahrenheit. So that's about 12 times hotter than the hottest day in June or July. And we make sure that there's no carbon when we're burning it, because if you have carbon or oxygen in the air when you're burning this wood, it'll catch fire. So in order to make it not catch fire, we throw a gas that won't react with the organic substance. And what we're left with is this activated carbon that has, and so when you burn a material at that really high temperature, you create all these little channels of the material, and it makes it even more porous and a better absorbent for picking things up. And so at the tiniest level, what does that actually look like? I remember I showed you a very simple picture of SpongeBob. This is a very high resolution image of what actually happens to the biochar at the tiny level. And so you can see the measurement down here. This is 30 micrometers, okay? To give you an example of how small these holes are, your human cells in your body are 100 micrometers. So this is 1/3 of that size. You can also up the temperature while you're making it to get different sized holes, and you can study that in the lab by, putting a bunch of different materials in the oven at different temperatures, and it'll give you, you run it through this very advanced imaging, and it can give you an idea of how temperature is affecting your material and what that might do at the molecular level for when you're designing it to pull things out of solution. And so the lab that I'm a part of is called the Waste Lab, Waste Applied in Science, Technology, and Engineering. And so on this slide, some of the things that we work with as well as pine bark are here. And so this lab was established in 2008 under the belief that marrying or combining sustainability with food processing and effective waste management is the path in the future to innovative and environmentally friendly science and engineering solutions. And I hope you believe me after today that waste is really a pressing issue. And unfortunately, in everything we do, whether that's mining, food, the clothes you wear, the roads you walk on, everything has waste. And it's our job as scientists and engineers not only to fix those problems, but to get innovative and to, rather than going to a chemical store and be like, okay, I need this really high grade activated carbon, see if you can make it from something that you can buy at Lowe's. And so again, my picture was going to be right here, but I really challenge all of you today to really think about embracing your waste and really think about loving what's around you, even though it might be viewed as trash, because you can really get creative with it.